Linear data structure stack. Let's have a look about stack and queue. First, we have to take care of the stack. What is mean by stack? Stack is some abstract data type. It follows some mathematical model. Abstract data type means it follows some mathematical models. For example, what is the stack? For a real-time example, a deck of cards or pile of plates. Let's have a look at a pile of plates. What is mean pile of plates means we're placing plates one by one. And the last place will be taken first. This is what happens in the stack operations. A real-world stack allows operations with one end only. That is the top only. You can insert and remove from the top only. This is what happens in the stack. At any time, we can only access the top element of the stack only. It means last in first one. The last element which enters will be first taken out. That's what happens at the last in first out. There are two operations: insert operation and removal operation. That is, insert means push and removal means pop. So let's have a look about stack representation. In push, let's have a look in the stack. There is 5 elements: 1, 2, 3, and 4, 5. And in the push, we are pushing an element. We are adding an element, 8 elements. That's 6th element we are adding. In stack, in pop, after pushing, it contains 6 of 1, 2, 3, 4, 5, and 6. Okay. After pop, 1, 2, 3, 4, 5. The last will be popped out. This is what the stack represents. It's a simple representation so that we can able to understand. So the basic operations: push, pop. Those are the basic operations in stack. Pushing means storing an element in a stack is called push operation. That's storing, that's pushing. Insert an element in any stack is called pushing. And pop means removing an element from the stack. Removing means deleting some element. That happens only in the top of the element. So to check the status of the queue, first there is 3 things. That is big, is full, is empty. And for every operation, we must know where is the pointer is. By using the pointer only, we can able to operate. We can be able to do these 3 operations. That is peak, is full, is empty. Peak means get the top element. It shows the pointer shows the top element. When it shows the top element, we can understand whether it is full or not. Okay. Is full means with the pointer is pointing to the final destination. Let's see, because the stack contains 5. If stack can able to store 5 elements, if the pointer is in the 5th element, then the stack is full. So is empty. Is empty means if there is 5 elements, the pointer shows in the 4th element. That is only one empty space. That's what's called is empty. So there is an empty space in the pointer, so that we can able to add an element in this place. The pointer in the stack always represents the top of the stack called top. The pointer always represents the top element. That is, if there is 5 elements, 5 spaces in the stack, and we have 4 elements, the pointer always points the 4th element. Okay. Now algorithm: seek. Begin procedure peak, return stack of top. If the top is seek, top is present, then return stack top in procedure. So is full if the top is equal to maximum size. Maximum size if there is 5 elements, same maximum 5 elements. The top element with the pointer points the 5th element. There is also a 5th element is there. Then it is full. Okay. Maximum size equal to the top element. Then it is called is full. Then return true. Then we can able to we can't able to operate push operation. Only we can able to do pop operations. Else return false and if. So is empty. Begin procedure is empty. If top less than 1, return true. Top less than 1, return true. Else return false. If there is only one space left means this is, and there is an empty space there, so we can able to add an element. This is what is empty. Then I will say push operations. So basic operations are push and pop. So we are going to check how the push operations happens. Okay. Next. Push operation means check if the stack is full. If the stack is full, then give an error message and exit. Why? Because if the stack is full, we can able to add any element, right? So the stack is not full, increment top to point the next empty space. It's 5 elements. There is 5 elements. There is 5 spaces and 4 elements, and the pointer increment to 5th element, so that and the 5th element we can able to push an element. Okay. So add data element to stack location where top is pointing. So in this place we can able to add something. Return access. So this is what happens. There is A, B, C, D is first already existing elements, And after push operations, the stack will be, and the stack points D, this top element. So after after pushing, the D will be added to the top of the stack. Then the pointers points the E push. This is how it happens in the push operation. Algorithm: if stack is full, done now. If else, top equal top is full. Getting increment one location. Then stack of top equal to data. We have to insert the data in the top element, top pointer. Next, pop operation. Check the stack is empty. If the stack is empty, produce an error and exit. Stack is not empty. Access element at which top is pointing. Decrease the value of top by 1 and return successful. So here what is the point is, if the stack is empty, there is no element, then how could you erase an element? How could you able to access an element? This is not erasing, this is accessing element. So we are taking the element from this, that is equal to a deletion of element, but not deleting. We are accessing element and use it for another purpose. So the stack is not empty, we can able to access the element. That's what happens to the pop element. So this is a pop element. We are popping out E. So A, B, C, D, and E. And after popping A, B, C, D is present, E is taken out for accessing, so doing some operations. So pop algorithm, making pop strong. If the stack is empty, return none. Empty means we can able to do any operation, so just get out of this place. And if else, data equal to stack top equal to top minus 1. That is, we are reducing one element, that is E. E is a top pointer, that is top. Now we are reducing top minus 1, and this is top D. And procedure.